If not, you can look on with somebody during work time. Okay, so we're at the top of page 8, and question 27 says, after solving the equation 2x squared plus 5x minus 3 equals x squared plus 4x plus 3, Gustav got called to the office and leaves his team. When his teammates examine his graphing calculator to figure out how he found his solution, they only see the graph of y equals x squared plus x minus 6. Consider this situation as you complete the parts below. Okay? So what did Gustav do? Anybody want to guess? Yes, sir. Right, like setting it equal to 0, but he put a y there so that he could graph it, okay? So if we have 2x squared on this side and x squared on this side, subtract the x squared, that's going to get us x squared. Take the 4x from over here, subtract it, that gets us the x. Take the 3, subtract it from this negative 3, that gets us negative 6. Okay, so basically, he's taking everything on the right side of the equal sign, doing the inverse operation to it, and moving it over to the left-hand side, okay? If we also set that equal to 0, it looks like this algebraically, right? The x squared plus x minus 6 equals 0. Gustav, is that his name? Gustav? I want to call him Gustavo. Gustav sets it equal to y so he can graph it. He's putting it in his calculator, but we're going to set it equal to 0 so we can solve it algebraically, okay? We solve it algebraically. We're going to factor it. If you prefer to do the quadratic formula, you could do the quadratic formula right here, but this one was very easy, so I did it in my box. I put the first term x squared in here, the third term minus 6 in here. For my x squared, I got x and x, and then I needed to see what factors of 6 add or subtracted to positive 1. So I determined that it was positive 3 and negative 2. Therefore, we would fill in this box with what? Positive 3x, yes. And we would fill in this box with? Negative 2x, okay? Those would combine to get our 1x, okay? To get our solutions, we would set each of those binomials equal to 0. So I did the one across the top first. No coefficient, so it's just the opposite. I did the one down the side over here. No coefficient, so it's just equal to the opposite. That gets me 2 solutions. So let's check them. Yes. Yes, I can. Oh, wrong way. Not that way. Is that better? A little bit more? Or you want to move up here? If I zoom in too much more, it starts cutting off the sides of my paper. Better? Okay. Right there. Okay. So now we're going to check our solutions. So let's plug in the 2 first. If we plug in 2 to this original equation, way back up here, right? We're going to have our 2x squared plus our 5x minus 3 equal to x squared plus 4 times x plus 3. Then we solve using order of operations. So we want to square first. 2 squared is 4. 2 times 4 is 8. 5 times 2 is 10. Then we're going to add and subtract from left to right. 8 plus 10 is 18. 18 minus 3 is 15. Okay? Then on the right side of the equal sign, 2 squared is 4. 4 times 2 is 8. Then we add and subtract from left to right. 4 plus 8 is 12. 12 plus 3 is 15. Does 15 equal 15? Yes, it does. Okay? So that's a good answer, right? Pretty much what we expect. Let's check our negative 3. And again, we're going to take the negative 3, plug it back into the original equation all the way back up at the top, and then simplify using order of operations. So negative 3 squared is 9. 9 times 2 is 18. 5 times negative 3 is negative 15. And then subtract from left to right. 18 minus 15 is 3. 3 minus 3 is 0. And then on the right side, after we plug in our negative 3 squared is 9. 4 times negative 3 is negative 12. So 9 minus 12 would be negative 3. Negative 3 plus 3 is 0. We like both answers. Okay? Both of them are good. No extraneous solutions on this one. Any questions so far on part A? We're good? All right, awesome. Maya solves, let me move it up just a tad in case anybody's still writing. Maya solves 2x squared plus 5x minus 3 equals x squared plus 4x plus 3 by graphing a system of equations and looking for the points of intersection. What equations do you think she uses? And graph these equations on your graphing calculator and explain where the solutions to the graph exist on the graph. You're going to come back to this when you get into your groups of 4, but for now, you can write down what you're going to need. You're going to need 2 equations. The first one's going to be equal to what? Well, they're both going to be y equals something. And the 1 and the 2 just mean the first line and the second line. You need 2 of them typed into Desmos. The first one should be your left-hand side of the equation, the 2x squared plus 5x minus 3. So the second one should be the right side of the equation, the x squared plus the 4x plus 3. You're going to graph those two, and then you're going to write down what are the points of intersection. Okay? Which means your solutions will be something. Hint, look back at part A if you need to check it. Okay? So where does Gustav get the equation y equals x squared plus x minus 6? We sort of already answered that. We said that he basically combined like terms on one side of the equation. Moved them all over to one side. We set it equal to 0. He set it equal to y. So that he could graph it. Okay? Any questions on page 8? Anybody still writing? Okay. Flip over to page 9. Okay. You can sort of fill some of this in while I'm talking through it, or you can wait and do it in your groups, or discuss it with your groups, kind of, however you feel comfortable. But part D just says, how many solutions will the equation y equals x squared plus x, y equals x squared plus x minus 6 have? And how do you know? Part E, use the axes to sketch a graph of the equation y equals x squared plus x minus 6. How can you see the solutions to the original equation, where we have the 2x squared part on the left and the x squared part on the right, in the graph x squared plus x minus 6? They want you to graph all 3 of them now. Okay, so the original 2 you did on page 8, but now they also want you to graph the x squared plus x minus 6. So you're going to put them all on there, and you're going to see how the 3 of them relate. If you want to type it into your Desmos graphing calculator while I'm talking, that's fine. Okay? And that's going to finish up question 27. Okay? All right, let's look at question 28. Anybody have any idea how to say this person's name? I'm going to go with Yahira. Yahira would be H. Okay. Yahira cannot figure out how to solve 20x plus 1 equals 3 to the power of x algebraically. So she decides to use her graphing calculator. However, when she graphs the equation y equals 20x plus 1 and y equals 3x, so she just did two different lines in her calculator, did them each separately, she gets this graph at the right over here, right? After studying the graph, Yahaira thinks there are no solutions to 20x plus 1 equals 3 to the power of x. What do you think? If you just saw this on your screen, what would that mean to you? You guys have used Desmos enough that you should do what? Pick it up and move it, or zoom in or zoom out, right? Because they're not intersecting in this window, but look what's happening right here. What is this going to indicate to you right here? They're getting closer together, right? So don't you want to see what's going to happen like right here? Right? What do you think is going to happen over here? It's likely that that's where they're going to be intersecting or crossing, okay? So write down that Yahaira should zoom out or pick up her graph and move it. Of course, she's using a graphing calculator. They function a little bit differently than Desmos. Hopefully, we'll get a chance to use some at some point, but we have enough right now for the calculus classes, but not for the pre-calculus classes. Anyway, when you work in your groups of 4, you're going to type the 2 in, and then you're going to write down any points of intersection for those 2, okay? Flip over to page 10. What should solutions up to the equation 20x plus 1 equals 3 to the power of x look like? In other words, will solutions be a single number, or will they be the coordinates of the points? Okay? The short answer is this. Solutions are found at the points of intersection, and they are going to be the x values. So if you have some number, comma, some other number, which one is the x? The first one or the second one? The first one, right? X, Y, and it always goes in alphabetical order, so it's got to be the first one. Okay. Yahaira's teammate Emma starts to solve by subtracting 1 from both sides of the equation. When she graphs her system later, she uses the equation y equals 20x and y equals 3 to the power of x minus 1. Will she get the same solutions? Yes, as long as she types it in the calculator correctly, she'll get the same thing. Test your conclusions using your graphing calculator. If you have points of intersection, write them down. And then the x values are going to be your solutions. Then part D, they want you to discuss with your team why Yahaira cannot solve the system algebraically. What do you think? So underline the part that says, what do you think? And so you're going to start your sentence something like, I think, blah, 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 blah. Okay? All right. Oh. Then in your groups of 4, you're going to finish up page 11, and then that's it for that section. All right. Go ahead and, well, let's see. Go ahead and